all the things today so that we can start with the road estimation in the next class. Okay. So in the previous class, we had discussed some of your septic tanks, right? We had covered this one, and then we had covered a simple one. Okay. So today we will look into a problem which has septic tank along with a soak pit. Okay. So in the previous class, I had just given you an overview of this. So today we will solve this in detail. Okay. So you can observe here in the section what we have. We have a septic. We have a septic tank. Okay, we have a septic tank. Along with that, we have a soak pit at the right side. So the effluent from your septic tank goes to your soak pit. Okay, as the name suggests, it soaks in all your liquid and your soil absorbs all that water. Okay. So all these things have been given. So let us look into what is the thing that we need to cover. So we have to cover earthwork in excavation. Okay, simple. Then foundation in base. Okay, foundation base in CC. No problem, very easy. First class brickwork masonry, meaning the walls. Okay, we will solve using long wall, short wall. Then Rcc roof slab cover. Okay, no problem, very easy. And then plastering. Okay, so all these 5 things we need to cover. Okay, so we will look into how to, now we will look into how to calculate the dimensions for your excavation. Okay, excavation. Okay, can anyone just add all of these values so that we can get the total height of excavation required, right, from ground level to base? Yeah, get a calculator and add 1.08 plus 50 centimeter plus 50 centimeter plus 40 centimeters. What is the value over here? Someone quickly add. Okay, 1.08 plus 0.5 plus 0.5 plus 0.4. This you need to add. Then this dimension is given. Length is given. You can observe here 8.4. Okay. Then we need to calculate what is the breadth. Okay, what is the breadth? They have not given. They have given this first wall, right? This is your first wall thickness. Okay, so this has been given, but the entire overall is not given. So I have calculated that and written over here. It is 3.4 meters. Okay, 3.4 meters. How? So into in is 2 meters. Okay, into in is 2 meters. Into in plus from here going up to here, right? Going up to here, we need to calculate what is this. So how much is that? From in, we need to come till the outer edge. So 50 centimeters, right? 50 centimeters plus this offset. Offset of this PCC bed, sorry, CC bed, offset of this CC bed. So can you observe they have not given us any offset over here, any offset. That dimension is not provided. Okay, offset dimension is not provided, so we need to calculate what is that offset. So what I'll do is I will calculate over here. You can see I have written a calculation. So CC bed offset is equals to, so this 8.4 we know out 8.4 is given minus, okay, minus this entire thing from here to here. If you minus and then divide by 2, you will get this offset, right? So how much is this distance? Outer wall edge, right? It is this into in distance, that is 7 meters. 7 meters into in is 7 meters plus this wall thickness 50 centimeters plus 50 centimeters, meaning 1 meter. Total you have to add. So it is 8 meters, right? 8 meters. So 8.4 minus 8 is equals to 0.4, right? Then half over here, half over here. So divided by 2, it is 0.2. So the offset is 0.2. So this entire thing will be what? It will be 50 centimeters plus 0.2. Okay, on this side and on this side. So it will be 3.4. Okay, so now we know the excavation. We know the length 8.4. We know the breadth 3.4 and height. Height, what is the height? Has anyone calculated height? 1.08 plus 1 meter plus 0.4. So that is your height of excavation, or what we call as depth. Okay. So that is what you write over here in the first thing. Earthwork in excavation, septic tank. For septic tank, 1 in number, 8.4, 3.4, and the depth is 2.48. Okay. So now we are done with septic tank. Now we will calculate for soak pit. Okay, the soak pit is in circular cross section, right? It is circular. So what we will do, we will take out to out, right? Out to out distance or the diameter we will take. So it is 3.6. Okay, so you can observe here 3.6 is given. The outer diameter is 3.6. So pi by 4 into 3.6 squared into the height of your soak pit. So height of your soak pit is given as 4 meters. So multiplying cross-sectional area, right? This cross-sectional area into the height will give you the excavation depth. Okay, so I hope I'm clear over here. So that is what they have given over here, pi by 4 into d squared into depth, that is 4 meters. So you get total excavation required for soak pit is 40.72. That is written over here. Okay, so totally it will be 111.54, 111.54, adding both these. Okay, excavation is clear. I hope excavation is clear. If you have any doubts, please let me know. Then. Okay, you guys are able to hear me clearly? Are you able to hear me? Up till where did I explain before the connection went off? Just let me know. Up till where I had covered before the connection went, so that I can explain that those things once more. Are you guys able to hear me? Just let me know.
Soak pit, sir.
Soak pit diameter over here.
Sir. Sir.
Okay. So septic tank is clear. I hope septic tank is clear. Then moving on to soak pit. Okay. So soak pit, as I've told you, it is a circular cross section. So pi by 4 into d squared. So the d is your what here? D is the dimension or the diameter of your soak pit. Okay, out to out. So it is 3.6 and the height is given as 4. So pi by 4 d squared into height, that is 4 meters. Okay, so into 4. So that is what we have written over here. So add both of these and you will get your total earthwork in excavation, that is 111.54 cubic meter. Okay, you have to add both of this and then we will get the earthwork in excavation. Next. So we have a foundation bed in septic tank, right? Foundation bed in septic tank, and we do not have a CC bed in your soak pit. So you can skip on that. Only for septic tank you need to calculate. So dimensions will be same, right? Length and the breadth will be same. Only thing that will vary is your depth. Okay, depth or the thickness of your CC bed. So that is 0.4. Okay, now moving on. So we have three walls, right? We have four walls, but in 3 steps. Okay, we have 4 walls, that is 2 long walls and 2 short walls. Okay, so these we will consider as long walls. Okay, these in this direction we will consider as long walls, and this direction as short walls. So 2 long walls and 2 short walls, and in 3 steps. So this is your first step of 50 centimeter thickness, second step of 40 centimeter thickness, third step of 30 centimeter thickness. Okay, 3 steps starting from bottom. Okay, and the respective heights have been given. Okay, first step height is 50 centimeter, second step height is 50 centimeters, third step is 1.08. Okay, so that is what we will calculate now, starting from the bottom. So suppose this is your bottom step. Okay, suppose this is your lowest step. So in distance we know is 7 meters in the length, and in breadth it is 2 meters in. Okay, so this red color which you can see here is your long wall, which we have divided in this fashion, and then this is your short wall. Okay, starting from here, ending over here in blue, you can observe. Okay, so now what is this length which I have shown over here? What is this length of your long wall? Length of your long wall starts from here going up to here, right? So in 7 meters, in 7 meters plus this wall thickness we need to add over here, and wall thickness over here. So the first step is what? 50 centimeter thickness, right? So 50 centimeter over here and 50 centimeter over here. Totally it will be 1 meter. So for 7 plus 1 meter, meaning it is 8 meters, right? 8 meters. And what about the length of short wall? What about the length of short wall? It will be from here up till here, right? So it will be nothing but 2 meters itself, 2 meters itself. So this is for your first step. Okay, so that is what you have written here for long walls. First step, right, of 50 centimeter thickness, 2 number of long walls, 8, right? And then this is your length. Sorry, this is not 0.5. Okay, so it will be what? Length, sorry. This is the thickness, 0.5 of your first step. That is your first bottom step, 0.5. And what is the height? Height I've shown you in the section. It is 50 centimeters. Right, height is 50 centimeters. So that is what we have written here. It is 0.5 into 0.5. Similarly, what we will do, we will calculate for second step and for third step. So for second step, it will be what? So for second step, so second step wall is how much? 40 centimeter in thickness. Okay, it's 40 centimeter in thickness, meaning it will be 7 plus 40 plus 40, meaning 7.8. 7.8, and for short wall, it will be same, 2 meters, no difference. Now, for third step, it will be what? 30 centimeter is the wall thickness for third step. This is 30 centimeter for third step. So it will be 7 plus 30 centimeter plus 30 centimeter, meaning 7.6. This is for second step, and this is for third step. Length of your long walls, and length of your short wall will be 2 meters for all the steps. Okay, length will be 2 meters for all the steps. Respectively, what we have done, we have written over here, and then we have written the respective thicknesses of your walls, and then this is your height of your each step. Okay, and then you can observe here for short walls, the length is 2 meters fixed. Okay, in all the steps, and their respective thicknesses we have written and their heights. Okay, so this is how you can calculate for brick masonry. Okay, for brick masonry in your septic tank. Okay, is this clear? Is this part clear? Calculation of brick masonry. No problem. Please let me know, okay, if you don't understand any of the calculations. Then moving on to your next thing. So we are done with brick calculations. Next, roof slab calculation. So roof slab, let us observe from where to where it is provided, from starting from where? Starting from first step. Going up to edge of your first step. So this is your what? RCC roof slab. So this dimension we need to calculate from here. So this is your dimension, and breadth wise also the same thing. Starting from the edge of your first step, going up to edge of your first step. I think someone's mic is on. Aryan's mic is on, I think. Can you please unmute? Okay, thank you. So RCC roof slab, as I've told you, it is given from first step, right? From first step. So this wall thickness is what? 30 centimeters, right? So 2 meters plus 30 centimeter over here and plus 30 centimeters over here. Similarly, for 7 meters, that is the length. So 30 centimeters over here you have to add and 30 centimeters on this side. So 7.6 by 2.6. That is the size of a roof slab. And what about the thickness? Thickness is provided. It is 8 centimeter. 8 centimeter thick RCC slab. So you can write down all those details. Okay. So we have covered RCC roof slab. Now, next, roof cover for soak pit. After septic tank, we have to give a roof cover for soak pit as well, right? So it is entire thing. It is provided entire thing. So it will be 3 pi by 4 into d squared, pi by 4 into 3.6 squared, right? And the thickness is same, 8 centimeters. Okay, so that is what is written here, pi by 4 d squared into thickness of a roof slab. So add both of this, you will get the total RCC roof quantity, RCC roof slab quantity. Okay. Now, after roof slab, we know that there are some openings which are provided, right? In your roof slab, we need to provide your opening for manhole cover, right? We need to we need to provide a opening so that we can get into and we can do the maintenance works, right? So you can observe here a manhole cover is provided, manhole cover. So we need to deduct that part. So what is the size of the manhole cover? It is 60 centimeters by 50 centimeters, okay? So that we need to deduct. So 60 centimeters by 50 centimeters is the size of a manhole that we have deducted. Okay, only one manhole we have, one manhole. So for that we have deducted. Okay, and the thickness will be thickness as the roof slab itself. Okay, so from this 2.39 we have deducted your manhole cover quantity. Now we have calculated the total net quantity of roof slab cover. Okay, 2.737 cubic meters. Okay, so once we are done with RCC roof slab, last thing that we need to calculate now is your plastering work. Plastering work we need to calculate for all your walls. Okay, 2 long walls, 2 short walls. Inside surface we need to plaster. Remember, we have to plaster inside surface because your water and your drainage water is coming inside your septic tank, right? So you have to protect our walls so that so that it does not disintegrate, right? So for durability, we have to provide plastering, right? Cement plastering in 1:4 mortar. Okay, so 2 long walls, 2 short walls. We need to provide in to in, right? So this is the in to in distance is 7 meters by 2 meters, and the height of your entire wall. Height of your entire wall is what? It is 1.08 plus 0.5 plus 0.5. So this is the height which you need to plaster, and then this is the length of your long wall, and then this is the length of your short wall which needs to be plastered. So this surface we need to plaster, okay? This surface and this surface, okay, and this inside surface, entire thing we need to plaster. So long wall 2 in number, short wall 2 in number, okay? In to in distance is 7 meters and 2 meters. In to in distance 7 meters by 2 meters, and then this is the height, okay? Height of your long wall and your short wall. Okay, height of your long wall, short wall. We have got the quantity of your plastering work. So now deduction. Some deduction they have done in exam. You can do or you can skip this. Okay, exam. So this is very minor quantity wherein if you do not deduct, it will be fine. Okay, sides of baffle wall they have deducted. Okay, sides of baffle wall meaning. So this is your baffle wall which is provided, right? You can observe I have drawn a baffle wall, a 3D image of your baffle wall, right? This is your baffle wall over here. You can observe. So this is 20 centimeter partition wall, right? So 20 centimeter thickness partition wall. Sorry, it is a baffle wall, not a partition wall. Okay. So this is your baffle wall which is provided in between, right? Lengthwise, sorry, breadthwise. Here also you can observe this is your baffle wall. So what they have done is for deduction, they have deducted this surface. Okay, this surface they have deducted, which I have marked in blue. Okay, this surface which is in contact with your long wall, right? Which is in contact with your long wall, like this. Your long wall is there, so that is in contact with your long wall, and similarly on the other side, right? On the other side. So this surface, what they have done, they have deducted because this is in contact, so no need to plaster this part. Okay, so the thickness is 0.2 and the height is 1.5 meters. Okay, 1.5 meters is the height of this wall. Thickness is 0.2 and in 2 in number because 1 over here, one surface is here, one surface is here. Okay, so they are 2 into 0.2 thickness and the height 1.5. They have deducted. Okay, if you remember in exam, you can do it. Even if you skip, there is not a big problem. Okay, not a big issue. Okay, so this is regarding your this numerical wherein we have calculated excavation quantities, then CC bed quantity, then we have calculated brickwork quantities in your walls, right? And then we have calculated what? We have calculated roof slab quantity, and then we have calculated plastering work, right? Plastering work. So 5 quantities totally we have calculated. So if you have any doubts regarding any of the calculation, please let me know. Any of the calculations if you have doubts. Or else we'll move on to the next numerical, next part. Is it clear, guys? Please let me know. Is it clear? Or any of the thing I should explain once more? Please, you can type in chat, or you can just let me know. You can talk and let me know. Is it clear? Shall I move on to the next numerical? So some of you might be having doubt why we have not calculated the quantities in your soak pit. Soak pit quantities, why we have not calculated. Because in the question, you can observe, prepare a detailed estimate of a septic tank shown. Okay, if they had mentioned septic tank as well as soak pit, then we would have calculated all the other quantities. But here only septic tank is mentioned, hence we have only dealt with septic tank. Okay, now in the next numericals, we will deal with a soak pit also, wherein we will learn in detail how to calculate the quantities in a soak pit. Okay, shall we move on to soak pit now? Shall we move on to soak pit calculations? In detail, we will solve 3 numericals. Okay, very easy. Soak pit is very easy. Okay, I hope you can see the screen. Can you see the screen wherein you have a soak pit? Let me know whether it is clear. Yes, guys.
Yes, sir.
Okay. So here you can see we are dealing with a soak pit, not with a septic tank. After the effluent passes through your septic tank, it comes to your soak pit, wherein your water is allowed to drain into your nearby soil. Okay, so this is a porous type of structure wherein your water is allowed to percolate into your soil. Okay, so you can observe here. So this is your ground level, and then a roof slab of 8 centimeter thickness is provided at the top. Okay, then the internal diameter is 100. Okay, internal diameter is 100 centimeters at 100 centimeters. Then this wall thickness is almost 20. Sorry, it is not 20 mm. It is 20 centimeters. Okay, it is 20 centimeters. So this wall is 20 centimeters. Then height of that wall is 50 centimeters. Okay, then this layer which you can see here is dry brickwork. Okay, the height of that is 250 centimeters. Okay, and the thickness of this is 20 centimeters. Thickness of this layer is 20 centimeters. Then after that, we have a second layer which is brick aggregate layer of 15 centimeter thickness. This here is 15 centimeter thickness. Similarly, it is provided over here. This goes around circumferentially. Okay. Then last layer we can see over here, it is coarse aggregate layer. This layer is coarse aggregate layer of 15 centimeter thickness. Okay. Then at the bottom over here, you can observe again we have a brick aggregate layer, right? Brick aggregate layer of 20 centimeter thickness. Then surrounding that we have brick masonry work in cement mortar 1:6. So this brick masonry work, right, you can observe here cement mortar 1:6, and here both are same. Okay, both are same, so we can quantify them in a single thing. Okay, so this part over here and this part over here are the same thing. Okay, similarly over the other side. Okay, so we have many layers over here. You can observe dry brick layer, then we have brick aggregate layer, then we have coarse aggregate layer. Okay, now let us calculate what is the overall depth. that we need for excavation. Let us just check. So you can observe ground level is here, right? Ground level is here, and this is the bottom layer. This is your bottom layer. So entire thing, what is the height? So it is 50 plus 250. So it is 300 centimeters, meaning what? It is 3 meters, right? 300 centimeters or 3 meters, starting from ground level 50 plus 250. Okay. So now we will excavate, as I've shown you, we will excavate this part. Okay, and we will excavate this part over here. Not the entire thing, okay, not the entire thing. Like this we will not excavate. Why excavate extra when we have to only excavate when we only need this part, right? So that is why we'll excavate only this part. As you've seen over here in the left hand side, I've shown you what is the excavation that is exactly needed. Okay. So now we have to excavate from here till here, right? From here to here we have to excavate. So that dimension we need, and we need this dimension, right? This bottom dimension. Okay, the thickness we know it is a 20 centimeter. This thickness we know it is 20 centimeters. Okay, let us now look into what is the diameter. Okay, diameter. So here you can observe in the plan. So this is your in-to-in diameter, that is 100 centimeters. Okay, 100 centimeters. This is 20. This is 20. Right. Then this brick aggregate layer is 15 centimeter. Coarse aggregate is 15 centimeter. So this is 15 centimeter, and this is 15 centimeters. Similarly, it will be here 20, 15, and 15. So now what is the entire diameter? What is the entire diameter over here out to out? Can anyone calculate? 100 plus 2 into what? 15 plus 15 plus 20. Can anyone calculate and let me know what is the diameter, overall diameter out to out in centimeters? Quickly, someone, out to out diameter. How much?
200.
200
Yeah, no, sir.
centimeters. 200. Okay. So this dimension, you mean it is 200. Okay. 200 meaning 2 meters. Right. 2 meters. And then what is this dimension now? What is this dimension? What is the diameter of this excavation layer over here? This dimension, I need diameter. So it is 100 plus 20 plus 20, right? This 20 plus this 20 plus 100. How much? 140, right? 140. Okay. Thickness we know it is 20. So excavation we have done. Excavation we have done. Next. So earthwork in excavation in foundation, upper portion meaning this part. Upper portion meaning this part, 3 meter and 2 meters. 3 meters and 2 meters is the upper part, and then this is your lower part. This is your lower part. Separately we will write them both. Okay. So what is the upper part dimension? So it is circular in cross section, right? So it will be pi by 4 into 2 squared. Pi by 4 into 2 squared into 3 meters height, into 3 meters height. And for bottom portion it will be what? Pi by 4 into 1.4 squared, right? In meters it will be 1.4 meters. So pi by 4 into 1.4 squared into 0.2 into 0.2, which is a height. Okay, so both of that you have to write separately, right? Upper portion and lower portion, right? Both of them, and then if you add both of them, in the end you will get the total quantity of excavation, earthwork in excavation. Okay, so is this part clear? Excavation part clear? Is it clear? Excavation, no problem. Okay. Then moving on to next thing that we need to calculate now. We need to calculate all the layer quantities, right? All the layers which have been provided, and we need to estimate their quantities. So now for that, what we will use is we will use this formula, right? For length, we will use this formula. This I have written clearly over here. It is pi into mean diameter, right? Not the external, not the internal. Okay. This is our internal diameter, which is 100, right? 100. And then this is our external diameter. Okay, depending upon your layer, it will be some distance. Okay, so we will take the central one. Okay, we will take the central one, that is your dm. Mean diameter we will take. So L into dm, that is what your circumferential length, right? So length we'll calculate using this formula, and then we are thicknesses of the respective layer we'll write thickness, and then the height of that respective layer we'll write, and we will calculate. Now for your brickwork, right, starting from your brickwork in lower portion, brickwork in lower portion, let us just look into where is that. So this is your brickwork, right, brick masonry work. So this is in your lower portion, right? This is in your lower portion, and then we have the same thing in your upper portion also. Okay, so we will write a lower portion first and then upper portion. Now, what is the mean diameter? Can anyone calculate from here to here? What is the mean diameter? 100 plus 100 plus what? 100 plus what? Answer please. 100 plus. From here to here, I need the mean diameter. That is the center to center diameter. 100 plus what? 20 by 2, right? Half of that on the one side and half of that on the other side. So it will be what? 120 centimeters. Correct? 120 centimeters. And what is the thickness of that? 20. Right? 20 centimeters thickness. We have calculated mean diameter. So what is the length? Length is pi into this mean diameter, that is 120. Length into mean diameter 120 into height. If you do, height is 0.2, right? Into height, if you do, you will get your total quantity. This is for your lower portion. Similarly, can anyone answer for upper portion? Upper portion, can anyone calculate for upper portion? Can anyone tell me the steps? I need dm. What is dm? Can anyone calculate for upper portion? In centimeters. And then total quantity. No need of calculating, you can directly answer for dm for this brickwork in upper portion. What is the dm? This thing which I have shown in blue. Same thing, right? dm is same what I have calculated in the bottom part. Same thing, diameter will be at the top portion also. So it will be 120, right? Same thing. So multiply length pi into dm, you will get length, and then length into depth of that section, right? You will get the total quantity. What is the depth? It is 50. Right? Length into 50, you will get the total quantity. Okay. So this is for your brickwork in your bottom portion, and then separately you have to write for your upper portion. Okay. Separately you need to write for both of these. Next. Next layer which is there, we have this dry brick layer which you can observe. Dry brick layer, right? Dry brick layer. So the diameter, the mean diameter will be same for this thing also, right? Same for our dry brickwork also, the mean diameter will be same. So 120 will be dm, mean diameter, pi into dm, and then length into the depth. What is the depth? It is 250. Right? It is 250. So you'll get the quantity of that dry brickwork. Next, after dry brickwork is over, then the next layer is what? Brick aggregate layer. Brick aggregate layer. So mean diameter will be starting from here, ending up till here. So we need to calculate this diameter. So what is this diameter now? So into in is 100, into in is 100, right? 100 plus this 20 plus this 20, right? 100 plus 20 plus 20, 140. 140 plus this 15 by 2 plus 15 by 2, right? So 100 and how much I told? 140 plus 15. 140 plus 100 plus 15 is 155, right? So this will be what? 155. So 155, and then height. What is the height? Same, 250. Height is same, 250. So similarly, you can get the quantity of your brick aggregate layer. Brick aggregate layer. Then lastly, for your coarse aggregate layer. Coarse aggregate layer. So it will be what? It will be from here, center of this layer, going up to center of this layer. So diameter. So 100 is the into in diameter plus 20 plus this 15, right, plus 15 by 2 on one side. Similarly, on the other side, you will get the diameter, right? Something diameter you will get, that diameter you substitute in this, you calculate the length, and then the depth is 250, same. Depth is 250, no need to change the depth. You can observe all the layers are of the same height. You will get the quantity in meter cube. Okay. So after quantity of your layers is calculated, the last thing that we are left out is your RCC roof cover, right? RCC roof cover, which is provided at the top, you can observe. So what is the diameter of that roof slab? Diameter is 100 mm, which is into in 100 centimeters, which is into in, plus this wall thickness over here, plus this wall thickness over here. So it will be 100 plus 20 plus 20, it will got 140. At 140, so pi by 4 into d squared, right? Cross circular cross section it is. So pi by 4 into 140 squared into height. Height is 8 centimeters, right? 8 centimeter thick RCC slab. So with this, all of your calculation is over. All of your calculation. Have we left out any of the things? We have calculated all the quantities, right? Okay. So one more quantity we are left out is your brick aggregate in your bottom section, right? This we have not calculated. This. Right, we have calculated brick aggregate in this layer, but similarly we have brick aggregates over here also, right? So that we need to calculate. So it is entirely filled. Okay, it is not circumferentially, it is filled entirely at the bottom. The entire thing is filled. So the diameter is what? Diameter is into in. It is 1 meter, right? 1 meter is the diameter. 1 meter is the diameter of this, and the thickness is what? 20 centimeters. So you can get the quantity at pi by 4 into 1 squared into 0.2. You will get the quantity in meter cube. So you can observe all of these layers we have calculated, and we have finished the quantity estimation. Then let me show you in the tabular form, right? So brick portion in lower, brickwork in lower and upper portion we have covered. Then dry brickwork we have covered, right? Dry brickwork. Then 50 mm size around the soak pit and at the bottom of the soak pit. This is what? Brick aggregate, right? At the last which I calculated, brick aggregate around the soak pit and also at the bottom of your soak pit. I have calculated. Then coarse sand, that is coarse aggregate. Coarse aggregate in your so around your soak pit, right? We have calculated. Then we have calculated precast roof slab quantity. Okay, so precast roof slab quantity we had calculated was pi by 4 into d squared into 0.08, right? We had calculated this quantity. That is 0.123 meter cube. Okay, so now we need to calculate the steel. Okay, we need to calculate the steel. So we will assume that we are using mild steel bars. Okay, mild steel bars at 10 kg per square meter. 10 kg per square meter. So this thing is what is the square meter now? What is the square area? So pi by 4 to d squared is the square area. Pi by 4 into d squared is the square area. So this square area multiplied by your this thing into 10 kg per square meter, right? So multiply that, you will get 15.4 kgs of steel is required in your RCC roof slab. Okay, surface area into this given weight, right? 10 kg per square meter. So if you multiply that, you will get the total quantity of steel required. Okay, mild steel bars that are required in the RCC roof slab. Right, RCC roof slab needs some reinforcement, right? So we need to calculate that quantity as well. So we are using this standard, that is 10 kgs per square meter. We are using mild steel bars. Okay, so we need to calculate the area, multiply that by 10. We will get the total quantity of steel. It is 15.4 kgs. Right. With this, the numerical of your soak pit is over. Soak pit is over. Right. Very easy compared to your other numericals like your septic tank and your manhole. Soak pit calculation is pretty easy. Okay. So just you have to calculate the mean diameter and then you have to estimate the quantity. Okay. If you have any doubts, please let me know in any of the calculations. I will explain once more if you require. So this is also a very basic one, very basic numerical. So This might be asked in our exam, but for lesser marks. Okay. Okay. So is this clear, guys? Is this clear? Please let me know whether this numerical is clear. If you didn't understand any of the thing, please let me know. We have time. I'll explain once more. Clear? Is it clear? Yes or no? Okay, so that is dealing with the soak pit. Next. So similarly, we have to solve all the problems of our soak pit. Okay, the dimensions may vary. The dimensions may vary, and the height may vary, or the layers may vary, right? Layers. So we can observe here 3 layers are provided, right? Along with your main layer, 2 additional layers, right? Like your coarse aggregate, brick aggregate, these layers have been provided. So these layers may vary. The thickness of these layers may vary, right? But that quantity calculation method will be the same. Method will be the same, just you need to substitute the dimensions respectively, right? Length you will calculate as pi into dm, and then quantity you will calculate how length into depth of that section. Okay, so the method will be the same, just the dimensions and the layers will go on varying. Yeah. So can we move on to the next numerical? Next numerical, let me know. If this is clear, we will head on to the next numerical. Right, so this is very easy compared to your previous one, wherein we do not have any extra layers. So you can observe. So only brick layer is there, right? Only brick layer is there, and then there is no extra layer like this which is provided. No extra layers like we had in the previous one. So much of a calculation is reduced, right? But you can observe over here inside. Okay, inside they have mentioned something that brick ballast of 50 mm size. Okay, brick ballast of 50 mm size, and then they have shown this circles. Okay, meaning that this is entire thing is covered with this brick ballast. Okay, entire thing is covered with brick ballast, but they have not shown. They have only shown it circumferentially. But while calculating, keep in mind that this entire thing is covered with brick ballast. Okay, keep that in mind. Over here also it is entirely thing. It is covered with your brick ballast. Okay, it is filled with your bricks. Okay. So, but the size is varying. You can see the size is 50 mm at the top and the size is 10 mm at the bottom. Okay, so that you need to consider while calculating. Next. So one more extra thing you can observe here. We have a Rcc support slab. The Rcc support slab is here. You can observe that we need to estimate along with this main roof slab. We have this support slab. Okay, so we'll consider that while calculation. Then rest all dimensions are given, no problem. Into in diameter is 150, and then wall thickness is 20. Then this layer height is 180. This layer height is 60. Okay, and then the overall depth of your soak pit is 300 mm. Okay, so all of this is given. Next. Now we'll look into what all we need to calculate. Let us just look into the question statement. Okay. So we need to calculate earthwork in excavation in foundation, no problem, very easy. Second class brickwork in cement mortar, that is this, right? This thing, walls. Then brick ballast of size 10 mm, that is provided in your bottom layer. And then brick ballast of 50 mm size, which is at the top. Okay, so that quantity next. Rcc slab over soak pit, right? Rcc slab, main slab, plus your Rcc support slab. And both of these Rcc roof slab, we have to calculate their quantities. Okay, so only 5 quantities we need to calculate, very easy, right? Not very complicated. Let us just look into what all we need to calculate now. Earthwork in excavation, 1 in number, right? Diameter is what? 150 plus 20 plus 20. It will be 190, right? 190 centimeters. And the depth of the excavation, it is given directly as 300 centimeters. So no problem, directly you can get excavation. Then second thing, we need to calculate second class brickwork, right? Second class brickwork. So mean diameter, we need to calculate mean diameter starting from here, ending up to here. So mean diameter is how much? Mean diameter is 100, right? Into in is 150. into in is 150 plus half of this, that is 10, plus half of this, that is 10 centimeters. So totally 20 centimeters, meaning 170 centimeters is this 170 at 170 centimeters. So 170 centimeter is the mean diameter. Then length, what is length? Length is pi into dm. That is pi into 170 centimeters. You will get the length. And what is the depth of this entire thing? Depth of this entire thing is 300, right? It is 300 minus this roof slab, minus this thickness of your roof slab. You need to do, remember, do not take entire 300, reduce this roof slab, right? Reduce this thickness of your roof slab. So how much is that? It is 300 is your overall depth of your brickwork, right? 300 minus 0. Sorry, it is 7.5, right? So directly we'll write 7.5, not 0.75. So 7.5. So you do that, you will get your depth of your brickwork, right? So in meters, it will be 2.925. Okay, so 3.3 meters minus 0.075, that is your roof slab thickness. If you reduce, you will get the height of your brickwork. Okay, so brickwork we are done. Then brick ballast, right? 10 mm size. Brick ballast which we have filled over here. So you can observe brick ballast 10 mm size is over here. This entire thing is filled with brick ballast. So our diameter, right? Diameter is what? 150. Diameter is 150 into in 150. So pi by 4 into 150 squared. Pi by 4 into 150 squared in centimeters. Okay, or else if you want to calculate in meters, it will be 1.5. 1.5 squared. Pi by 4. Let me write pi by 4 into 150 squared into the depth. What is the depth? 180. 180 is the depth, meaning 1.8. Because this entire thing is filled, right? No need to take off mean diameter, because this entire thing, it is like a cylinder that is entirely filled with this brick ballast, right? So cross-sectional area into the depth. So cross-sectional area is pi by 4 into 1.5 squared into the depth is 1.8. So this is for a brick ballast of 10 mm size. Similarly, for brick ballast of 50 mm size, you can do at pi by 4 into d squared by the depth, that is 60. Okay, so now we are done with that. Now the last thing which we are left out is this RCC roof slab. So you know how to calculate RCC roof slab, pi by 4 into d squared, right? Pi by 4 into d squared into this thickness 7.5 centimeters. So that is for your roof slab. Now one more slab is provided at this level, right? One more slab is provided, that is your support slab. Support slab 15 centimeters by 6 centimeters, 15 centimeters by 6 centimeters, right? And then there is some amount of bearing which is provided. You can observe some amount of bearing. So what we can observe, so this bearing is how much? It is half of this wall thickness, right? Half of this wall thickness. What is this wall thickness? It is 20 centimeters, right? Half of that will be 10, right? Bearing 10 centimeters on one side and 10 centimeters bearing on the other side. So what will be the total length now? What will be the total length? It will be into in distance, that is 150, right? Into in is 150 plus 10 centimeters bearing on this side plus 10 centimeters bearing on this side. So I will write directly as 20. So the total length is 1.7 meters, 1.7 meters, right? And then that is your diameter, right? 1.7 pi by 4 into 7 squared. So this is for a roof slab, and then this is for your support slab. Okay. But one more thing you can observe, they have given this dimension as 15 centimeters into 6. Okay, 15 centimeters into 6. So 15 centimeters is this way, right? And 6 centimeters is the thickness, okay, thickness of this roof slab. Okay, and then what is the length? Length we have calculated as 1.7 meters. Let me just draw it again. So 1.7 is the length which I have drawn, right? 1.7, and then this is the thickness, which is 6 centimeters. Okay, 6 centimeters is the thickness, and then this is your 15 centimeters, right? 15 centimeters is like this. Okay, it is a square slab, not a circular thing that is provided inside. It is just a support slab, right? Like this, it is provided. Okay, inside it is provided for your inlet pipe. Okay, so 6 centimeters into 15 centimeters. This thing 6 centimeters into 15 centimeters into your length. right, which we have calculated as 170 centimeters. So this is 170, and then the thickness is what, 6 centimeters, and then this is 15. Okay, so this, if you multiply all these three numbers, you will get the quantity of this slab. Okay, so I think with this we are done with this numerical, right? All of this we have calculated, all of this have calculated earthwork, then brickwork, then ballast, right? Two ballast, 10 mm and 50 mm size, then roof slab, okay, roof slab and RCC support slab. Okay, all of this we have covered, right? So I hope it is clear. Very easy problem, right? It will be over within 10 minutes. So if you have any doubt which you need me to explain, please, you are free to ask. If you didn't understand any of the calculation, please let me know. Okay, so I hope it is clear. I hope it is clear. So with this, moving on. So I think we are done with the soak pit. Okay, we are done with soak pit. And if you need a break, let me know. After a break, we can continue with your manhole problems, right? Manhole estimation. We can continue after a break. Okay, so it is 11:26. I think you guys also need a break. So 11:26, we will be back at 11:30. Fine, no problem. We'll be back at 11:30 after a few minutes of break. Okay, but do not leave the meeting. Do not leave the meeting. Stay in the meeting. Okay, we will continue in a few minutes. Okay, is it fine? We'll continue with the manual problems in the after a break. Okay. So we are back after a few minutes of break. Okay. So we shall continue with your manhole estimation, wherein I have explained what a manhole is. So manhole is provided at regular intervals, right, in your drainage system, wherein a person can go in and so do some maintenance work. Okay. It is also provided at junctions, wherein two or more right, drainage pipes are meeting. Okay, it is provided over there, and steps are provided. Right, steps are provided to get in and get out. Right, so that we can easily maintain our drainage system. Okay, you can observe here in this figure, wherein there is a manhole cover, right, and below that manhole cover we have steps, right, to get down and then provide and do some maintenance work or cleaning work if any thing has clogged up. Okay, so now we need to learn how to estimate, particularly for this all these quantities, right? Whenever we want to construct a manhole, we need to know what is the quantity that is required and what will be the cost. Right, so now we will learn how to estimate particularly a simple one, right? A simple manhole we will learn first, and then we will move on to some complicated ones. Okay, so shall we start? Shall we start? Shall we start? Yes. Okay, I hope you guys are here. Are you able to hear me? Yes. I hope I'm audible. Yep. Please, someone give confirmation that you are able to hear me.
Yes, sir.
Fine.
Yes, sir.
So these are some few numericals which are related to manhole calculation. Okay. So first manhole is a very simple one, wherein it is a circular one. Okay, it is a circular one. So internal diameter is 1 meter. Okay, internal diameter is 1 meter, and then we have a few layers. Okay, few layers. So the first thing that you can observe here is a brick wall. Okay, brick wall. Okay, wire cut bricks in cement mortar 1:4. So we have three steps, right? The top step is 20 centimeter in thickness. Then the next step is 30 centimeter in thickness. Okay, and the bottommost step is 40 centimeter in thickness. Okay, so no problem. So that if you observe in plan, if you observe that in plan, it will be observed, it will be visible as layers, right? So this is 20 centimeters, right? So this is 20 centimeters, which is the thickness of a first step. And then thickness of a second step is what? It is 30 centimeters, right? So this is what? This is 30 centimeters. The arrow mark which I have shown from here to here is 30. And this is 40 centimeters, right? So red color is for your first step, green color circle is for your second step, sorry, red color is for your right first step, second step, and sorry, this is for your third step, blue color, which is 40. Not this is also 30 itself, right? This is also 30. Okay. So this is for your third step, which is blue color ring, which you can observe is for your third step. And then this is for your PCC offset. Okay, PCC offset, right? Sorry, not PCC. They have provided CC bed, okay, cement concrete bed in cement mortar in a proportion of 1:3:6. Okay. So what is that offset now? The offset is 10 centimeters. You can observe that offset they have provided us 10 centimeters. So 40 plus 10, it will be 50. So all the things we know exactly now what all the dimensions. So first ring, red color is for first step, green color is for second step, blue color is for third step, and this black color is for your entire thing. Okay. So this is a circular cross section one which I've told you. So internal diameter 1 meter, all of this, and then let us look into the depth. Okay, depth. Then from here to here it is 2.6 from your bottom of your RCC slab going up to benching. Okay, this kind of slope is provided inside a manhole, right? This is your drainage pipe, right? This is your drainage pipe, and this kind of benching will be provided so that all the water will go into your drainage pipe, right? Proper drainage should happen so that because of that your benching is provided. Okay. So now what are the heights of your each step? 1 meter, 1 meter, 1 meter. Okay, 3 meters entire thing. Then 10 centimeter thickness, meaning 3.1, right? From here, starting from here, we'll go down up to here. We need, so 3 meters plus 10 centimeters plus 0.4. So this entire thing depth, how much is this depth now? Let us calculate. Sorry, it is at the top. So the depth is 3.5 meters. The depth is 3.5 meters. And what is the total excavation required? It is 1 meter plus 50 on this side plus 50 on the other side, right? So it will be 2 meters. 2 meters of diameter we need to excavate. So pi by 4 into 2 squared into the depth. Depth is 3.5. So we'll get the total quantity of earthwork in excavation. Easy. Next. So a CC bed we have, so the diameter will be the same, right? Diameter will be same, only the thickness will vary, right? Thickness of the CC bed is given as 0.4. Okay. So we have calculated the quantity of CC bed. Now moving on to calculation of your brickwork, right? Brickwork, we will divide it in 3 steps. Okay, starting from your bottommost step. So this is from here to here, it is 40 centimeters, right? But we need what we need from center, right? We need from center. So this will be what for? So this will be 30 plus 20, right? 30. So this thing is 30, right? This thing is 30 from here to here, which I've written over here, 30 plus this half of this. Sorry, it is not it is not that. So I've done a mistake over here. So it is not that. It is what? It is half of your wall thickness, right? It will be clear in your sectional view. In a plan view, it is a bit confusing. In a section view, it will be clear, right? So this is half. This is your half. So this diameter is what we are concerned about, this diameter. Okay. Starting from here, going up to here. This is your mean diameter. Okay, this is your mean diameter, dm. Okay. So 1 meter is in half of this over here, half of this over here. So it will be 40 by 2, that is 20 plus 20, right? 1 meter plus totally 40 centimeters. So it will be 1.4. Mean diameter is what? 1.4. 1.4 meters. Mean diameter. Now we know L is equals to what? L is equals to pi into dm. So length we have got. Then quantity will be what? Length into the height of that section. Height of that is 1 meters, right? Depth. If you do that, you will get it for the first step. Now moving on to second step. So from here up to here. So what is the mean diameter here? It will be, this way is 15 centimeters, right? 15 centimeters plus 100 plus 15. So it will be 1.3 meters. 1.3 meters. Similarly, we will calculate L and then we will calculate the total quantity. Okay. Now in the third step, it will be from here going up to here. This is for a third step. So for this step is 20 centimeter in thickness, meaning this half of it will be 10 plus 100 plus 10. So 1.2 meters. Okay, we have calculated per dm. So length is equals to pi into dm, right? Length we will get, and then quantity will be we will get as length into depth. And depth is 1 meters. Okay. So now we are done with brickwork calculation. We are done with this. All of this we have calculated. Next, moving on to cement pointing. Okay, cement pointing in cement mortar for inner surface. For inner surface, we need to calculate cement plastering or cement pointing, which we call as. Okay. So inner surface, meaning this surface we need to plaster, right? Inner surface. So it will be what? 1 meter, right? Yeah, directly it is 1 meter. So length will be what? Length will be pi into 1 meter. Pi into 1 meter. And then what is the quantity? Quantity is length into this depth. What is the depth of this entire thing? Entire thing is starting from here, right? 1 meter plus 1 meter plus 1 meter. Okay, 3 meters. Okay, so entire thing is 3 meters, but we need to deduct some. We need to deduct something. Okay, so because of this benching, right, because of this benching which is provided till this level, we will consider for plastering. Below this, we do not need plastering, right? Below this level, we will not plaster. What we will do is we will consider up till here only, not the entire 3 meters. So it is what, 2.6 meters. Okay, for plastering, we will consider the height as 2.6 meters. So that is what we have written here, 2.6 meters height, and then this is pi into 1 meter. Pi into 1 meter, we will get the total quantity as 8.17. 8.17. Then RCC or roof slab, easy, very easy. Pi by 4 into d squared into thickness of the slab. So what is the diameter? Diameter is from here to here. So it will be what? 1.4 centimeter for 1.4 meters. 1.4 meters, and the thickness is given as 10 centimeters. So directly you can get the quantity of RCC roof slab. So with this we have calculated all of these quantities. Earthwork we have calculated. We have calculated CC bed concrete quantity. We have calculated brickwork. Then we have calculated cement pointing. Then RCC roof slab. All of this is done. So this is a very easy numerical. This kind will not be asked in your exam, but for your understanding, we have solved this. So even if you have any doubts, please let me know. In this numerical, if you do not understand any of the, if you did not understand any of the steps, please let me know. I can explain once more. I hope it is clear. It is very easy. Okay, no doubts, no doubts, no doubts. Okay, moving on. So this was a circular one. Okay, this was a circular one. So now we will look into how to calculate if we have a rectangular manhole. Okay, if we have a rectangular manhole of this kind. So here you can observe this is a rectangular manhole, wherein this is a drain pipe which is going. Okay, this is a drain pipe. Okay, and in this section you will observe a pipe, and in this section you will observe a circular one. Right. So this is our pipe, and then this is our benching which is provided benching. Okay, and this is a rectangular one, and here you can observe this is your manhole cover. So at the ground level, which is here, okay, so your ground level is here, you can observe GL is written. So at the ground level you can only observe this cover, right? You think that the manhole is only this size because at the surface only this much is visible, but actually inside it is a very big structure. Okay, it is a very big structure. So now we will look into how to calculate all of these quantities. So we have roof slab, we have brickwork. Okay, no steps, only one brick wall, only one size brick wall. Then we have this benching, we have this sewer pipe, and then we have this CC bed. Okay, CC bed at the bottom. Okay, then in the plan it will be in this fashion. It will be visible in this fashion. So this is our manhole cover, which is visible at the top. Okay, manhole cover, which is visible at the top, and then this is your entire dimension of your manhole, rectangular dimension. Okay, then let us calculate now. So 1.3, say 1.136. So how is this 136? So this section is what? This section is L. You can observe it is LM section. So let us look into LM section. Which is LM section? This is our LM section. Okay. So how have they got 136? 136, 90 plus 23 plus 23. Right. So this is 136. This is your 136, which they have written 90 plus 23 plus 23. Meaning this is what this 136 is for your brickwork, right? Brickwork and not your PCC. So sorry, your CC. So CC will be somewhat like this, visible again. So which they have not drawn. Okay, CC is again which is visible, which they have not drawn. Okay. So this is for your brickwork. This plan shows your brickwork. Okay, do not confuse. This is not our entire section. Okay, this is not our entire section. This is just a section of your or your plan view of your brick. Okay, brickwork. Okay, so while calculation in your earthwork, do not substitute directly 136. Okay, we need to add some quantity, right? We need to add this 7 also. 7 plus 7 we need to add, and then we need to write. Okay, so do not make that mistake in the exam. Okay, so now what all we need to calculate? We need to calculate foundation. In cement concrete, we need to calculate masonry work, right? Brickwork, then RCC work. So RCC, sorry, not RCC work, it is RCC roof slab. Right, we have a slab over here, that RCC we are talking about. Then manhole cover we need to calculate. Then we have to calculate finishing in cement, sand, plaster. Okay. So all of these quantities we need to calculate. How many? 5 number of quantities are there. Okay. So let us now look into how we exactly calculate all these things. Okay. Now, first thing that we need to calculate earthwork in excavation, even though if they have not mentioned, please do calculate earthwork in excavation. It is very important quantity. Okay, earthwork in excavation. Earthwork in excavation. Let us look into what is the depth of our excavation that is required, starting from ground level going up to the bottommost level. So this is the depth which is required. So you can observe all the dimensions are provided over here. All the dimensions. Can someone add up and tell me how much is this? Add all of these. 15 plus 15 plus 220 plus 40 plus 20. Someone please add up and tell me what is this overall depth of excavation. Overall depth of excavation that is required. 15 plus 15 plus 220 plus 40 plus 20. What is the total quantity? Anyone? Keep a calculator with you and calculate along with me. Can someone give me what is the depth? It is 300 something, I guess. I think it is 310. Is it correct? 310? 310, is it correct? Can anyone confirm? 310, right? So depth is done. Calculate, okay? Calculate and let me know. Then moving on. With this we need to calculate the total thing from here to here and then from here to here. The length and your breadth. So length will be 120 plus 2 times 23 plus 2 times 7. Right? So it will be what? So it will be somewhere around 180. 180, and then this is 136, right? 136 plus 14. Entire thing is 150. 150. So 180, 150, 310. Okay. So that is for our excavation. I hope it is clear. Excavation. Then for a PCC bed, right? PCC bed is 180 into 150 into thickness. That is 20. The thickness is 20. This is for CC bed. Now, moving on next. Okay, so now we have calculated CC bed in foundation 1.8, 1.5, and 0.2 is the thickness. Next, moving on. Then in flooring, okay, in flooring we have CC bed. Okay, in flooring we have the CC bed, right? Benching, which we have provided. Right, this benching we have which we have provided. So this we need to calculate. So 120 and 90. And what is the height we will look into? So height is 30, right? 30 is the rectangular part. And then 10 we have something slope which we have provided, right? And so this 30 is for this rectangular part. Height of this is 30. And then we have this 10 which is for this triangular part. Okay, one is this side and one is this side. So 1.2 is the length. This is your width, and then this is your height, right? What they have taken is 30, which is for rectangular part, plus average, right? Average they have taken, that is 0 plus 10 divided by 2. Right? The triangular part they have taken as average. So it will be what? It will be 35 centimeters. 35 centimeters, which we have written as 0.35 meters. Okay, so I hope this quantity calculation is clear, both of this. Okay, for flooring, remember this is how you calculate for flooring, right? By what I mean by flooring is that benching, right? Benching which we have provided. Okay, so now moving on for brickwork. Brickwork, similarly, how we have calculated for long wall, 2 number of long walls, 2 number of short walls. Okay, so this red color which I have shown over here, red color, light red color, you can observe, or brick color which you can say is your long wall. So 2 number of long walls, this is one number of long wall, this is your second long wall. And then this is in blue color, light blue, which you can see is your short wall. So this is 1, and then this is 2 number of long wall, 2 number of short walls. So now what is the length of my long wall, which I've shown over here, like dimension line I've shown. So this is the length of my long wall. So it will be what? In distance plus this wall thickness over here plus this wall thickness. Okay, in distance is how much? So this is JK section. You can observe JK, J and K section at JK, which is over here, section JK. So in distance is how much? In distance is 120 plus my wall thickness. Okay, wall thickness is how much? Wall thickness is 23. Okay, so 120 plus 23 plus 23. It is how much? 166. Okay, 166. Okay, so this is for my long wall. Length we have calculated. Now the height of my long wall. Height of my long wall is how much? Height of my long wall is from here. Okay, 220 plus 40, 220 plus 40. Okay, now for short wall, height will be same for short wall, right? Height will be the same, but what about the length? Length will be into in, right? Length will be into in only. It will be from here to here, into in. So what is that length? Now let us look for this length. We have to look into which section? LM section. LM section we have to look in to identify the into in length. Okay, LM section is this one. LM section into in distance is 90. So this is 90. Short wall length is 90, and both of these walls are how much in thickness? 23 centimeters in thickness, and the depth we have seen it is 240, right? 240 plus how much? 220 plus 40. 220 plus 40. So all of these dimensions we have for your long walls and short walls. Length we have thickness, and then we have depth. Okay, so we are done with the long wall and short wall, meaning we are done with masonry work. We are done with foundation work. We are done with masonry work. Now we have to look into RCC work. Okay. So moving on to RCC work. So RCC work is here, right? So 1 meter, one in number, right? One slab. Then this is the dimension you can observe in the figure. Dimension of your RCC slab at 1.66 and 1.36 breadth. Okay, and the thickness of your RCC slab is given, right? No problem in calculation of your RCC slab. Then we need to calculate steel, right? Whenever we have RCC work, there is some steel which is provided in your RCC, right? As the name suggests, it is reinforced cement concrete, right? We need to calculate the reinforcement which is provided. So here, mild steel work in reinforcement and steps. Okay. So this how we have got this is A, B, C, D, and E. This is taken from your schedule, okay? Schedule of your bar bending. So which they are provided over here. You can observe bar bending schedule has been provided to us. So using this, we will calculate that. So A bar number A. Where is this bar number A? In this you can observe bar number A is going along like this. Okay, A number of bars. So what is the length of that bar? Length is provided over here. Length you can observe it is 100 mm hook length plus 1000 mm the straight to straight length, then plus 100 mm is the hook length. So what is the total bar length? It is 1200. Okay, 1200 mm. Okay, it is mm. So length we have number, how many number? 4 in number. Okay, 4 in number, and diameter is also given. Okay, so this is for bar number A. Similarly, they have provided for all the other bars. Bar number, bar C, bar D, and bar E. Okay, you can observe in the plan, there are many number of bars. Bar number A, bar number E, right? Bar number C. All of these bars have been provided. Also this bar number D. So you have to write down all of those from your schedule. Write down all of those along with their diameter, which is provided in the schedule. Write those down. Write the number of your bars, right? Number of your bars which are provided. Then write the length of your bar, which is also provided in your schedule. Right? This is the number. This is your length. And multiply both of this, you will get the quantity. Okay. So mild steel work in in your slab is done, right? In your slab is done. Then weight. We'll calculate now weight. So weight of this. Okay, weight of this total quantity 11.205 meters. Weight of 11.20 meter length of 12 mm dia, right? 12, all of these are 12 mm. So length 12 mm dia bars at, okay, 12 mm dia bars at 0.89 kg per meter. 0.89 kg per meter. How you get? This you can get from your formula, right? Phi squared divided by 162.2, wherein phi is what? Phi is 12, okay, the diameter of your bar. So if you substitute this, you will get this 0.89. Okay. So we can multiply now. We can multiply 11.2 into 0.89. You will get the total quantity of steel in kg. Total quantity of steel required in slab in kg. Okay. So we are done with that. Now we have been provided how many number of steps, right? 16 mm dia steps have been provided, and they have 10 in. We have 10 in number. Okay, 10 number of steps have been provided, and 16 mm dia steel steps have been provided. So 16, so you substitute here. 16 you substitute. Okay, 16 you substitute over here. 16 squared by 162.2. You will get 1.58 kg per meter. Okay, so the total length, that is 5 meters into 1.58. If you do, you will get the total quantity of steel required in steps. Okay, this is for RCC and this is for steps. Add both of this. Add both of this, you will get the total quantity of steel required. Total quantity of steel required is 17.87 kgs. All of this is done for your reinforcement calculation. Okay, reinforcement calculation. So you need to remember this formula. Okay, remember this formula. Multiply that number by the length. Multiply that number by the length, and you will get in kgs. Okay, you will get in kgs. So remember these steps. Now, moving on. Last thing. So one manhole cover is provided. Write one number. No need of any dimension. Okay, no need of any dimension. Write just a number. One number of manhole cover. Then cement sand inside plastering of your long walls, also your short walls. We need to do inside wall plastering. So 2 number of long walls, and how many number of short walls? 2 number of short walls. Length of long wall and short wall I have calculated previously. Same thing you can write, right? But this, remember, this is in to in. Okay, in to in distance of your long wall as well as your short wall. Okay, in to in distance, not your entire long wall and short wall, but in to in distance. Okay, and then this is the height of your long wall and short wall. 2.6. Let me just show you these dimensions in the sectional view. Okay, so the in to in distance, this is your in to in distance, which is 120, right? And then this is your 90. Okay. So what about the height? Height is 220, right? 220 is the height which we need to plaster into in. Okay, do not consider this part. Do not consider this part. 40. Do not consider 40 because there is already this benching and this cement concrete which is provided, right? So you can consider only height from here going up to here for inside wall plastic. So that is 220. Okay. So I hope this thing is clear. So now we have calculated this manhole cover also. We have calculated finishing. Okay. So all of these quantities we have calculated. So I hope it is clear. If you need any explanation, please let me know. If you didn't understand any of the calculations. So this is how you estimate for a manhole. Okay, for a manhole. Now, this was also a simple one. If it is clear, we will move on to the last numerical. Okay, so this is the last regarding a manhole, wherein we have a rectangular one. Okay, we have a rectangular one, and we have steps. Okay, the wall is made up in steps. You can observe. So this is 20 centimeter, this is 30 centimeter, and then this is 40 centimeter. Okay, so this is a bit complicated, but easy compared to your other problems, right? From your module 1, if you compare, calculation of your manhole quantities is very easy, and it is less time consuming. Okay, going wrong has less chances over here compared to your first module estimation problems. Then, yeah, I think we can continue with this. Yes, I've understood the previous one. Can we move on to the last numerical and finish the things off? Okay, so earthwork in excavation, the first thing always which you need to calculate, and cement concrete in your foundation, brickwork, pointing work, that is your plastering, your plastering of your inner surface, which you need to do. Then 20 mm plastering for floor and chamber. Okay, plastering for our walls and then plastering for our flooring. Then Rcc roof slab. Okay, 6 quantities we need to calculate. So in our exam, either this kind of numerical, right, the previous one, either this kind or the one I'm solving now will be asked. Okay, not the first one. In an exam, either this kind or either this one, which we are about to solve. Okay, this kind will be asked in our exam, not the first one. First one is very easy. That will not ask. That will not be generally asked in our exam. Okay, so let me just look into your cross sections. Okay, so it is a rectangular one, wherein we have this the brickwork, right? Brickwork over here. We have brickwork over here also. Okay, remember we have brickwork over here also, and then we have brickwork over here. Then Rcc roof slab 10 centimeter thickness. Then the first step is 20 centimeter. Second step is 30. Third step is 40 centimeter. What about this offset? This offset is 10. Okay. Thickness of my PCC, my CC bed is 20. The overall dimension is given clearly 300 by 190. 300 by 190. Now what about the depth? What about the depth? So this is your ground level. This is your ground level, right? Road level. So this thickness, that is 10 centimeters. 10 centimeters plus 60 plus 120 plus 60 plus 120 plus 50, right? Plus 50 plus this diameter 40 plus last thing 20. Okay, all of this you need to add. So 10 plus 60 plus 120 plus 50 plus 40 plus 20 is the overall depth. That is, it is coming around 300, starting from your road level going up to bottom. It is 300. Let us check if we are correct. It is over here. Okay. Right, it is correct. What we have calculated is correct. 3 meters or 300 centimeters is the depth, and then this is directly provided. So earthwork in excavation is clear. Then cement concrete in foundation, thickness is 0.2, no problem over here. Then, long wall and short wall, the main thing over here, long wall and short wall. So 3 steps: first step, second step, third step, starting from your bottom. So 2 in number. All of these are 2 in number, right? 2 number of long walls, 2 number of short walls. Then moving on to length. Length calculation, as I've shown in previous numericals, same thing, right? So you can divide your walls into long walls like this. Divide it into long walls in the same fashion, right? This is your long wall at the top. Similarly, there will be a long wall at the bottom, right? And then this into in distance is what is your short wall. This is your short wall. So short wall is also 2 in number. So for first step, long wall length is what? Into in distance, right? 200 is the into in distance plus this 40 over here plus the 40 over here. So it will be 280. 280 for first step. For second step, what? 200 plus 30 plus 30. So 260. Right. And for third step, which is over here, right? Third step. Okay. So for third step, let us look into what they have done exactly. So no problem for a first step. 280, which I've shown you, then 260, right? And then 1 meter. Okay, 1 meter, which is over here. Okay, 60 into in plus this 20 centimeters plus this 20 centimeters, which is totally 60 plus 40, it is 100 centimeters or 1 meter. Okay, 1 meter, and the height is respectively heights have been given. Okay, 60 centimeters, 120 centimeters, and then this height will be what? This height will be from here going up to here. So it will be 50 plus 40. It will be 90. Okay, heights have been given, and thicknesses have been given. Length we have calculated. So long wall is done. For short wall, very easy. For short wall, all the lengths will be 90. Okay, lengths will be 90. Respective thickness you can substitute over there 40, 30, and 20, and the respective heights also same heights. Okay, 60, 120, and 90. Okay, with this this calculation is over. Your brickwork calculation is over. Okay, so moving on to pointing work for your inner surface. Okay, for your inner surface, so long wall up to RCC slab. Okay, they have divided. How they have divided? Up to RCC slab and above RCC slab. Okay, long wall up to RCC slab, meaning RCC. So long walls up to this level. Okay, up to this level we have calculated separately, and then above this level we have calculated separately. Okay, so up to RCC slab and above RCC slab. Okay, up to and above. Okay, remember. So, but one thing. So this line is not over here. So this line is over here. The division line is over here. Okay. So long wall, short wall, in length we have to take for plastering, right? 290. 290, and then what is the height that we need to plaster? Height is 200 plus 50. 200 plus 50, that is up to this level. Okay, 200 plus 50. No need for plastering below this level because there is already concrete over here. Right, so this is below your roof slab, and then for above roof slab, that is length is what? 60, right? Length is 60 in long wall. And what is the length in short wall? It is 90. It is 90 same. Okay, 90 is same. But your long wall length has changed. Now height is what? 60. Height is 60. Here height also is 60. Okay, so this is how you can divide your plastering work. Okay, below your roof slab and above your roof slab. So why have we divided? Why have we divided? This is because the length of my long wall is varying, right? Length of my long wall in the below roof slab it is 200, and above roof slab it is 60. So we have divided it into two parts. If this was not divided, if it was the same, meaning the long wall was 200 here and 200 here, so we would have calculated it the same way. Okay, if it was like this continuously, we would have done it in a single manner. Okay, because it is changing, it is varying, we have separated it into two parts. Okay, so plastering work is done. Now what is left out? What is left out? So above long wall, below long wall is done. Then 20 centimeter cement plastering for flooring and channel. Okay, for flooring and channel, what they have done? Additional 30 centimeter for channel curvature. Additional 30 centimeter for channel curvature, meaning we have a channel which has curvature, right? Which is in circular form. So for that we will consider 30 centimeter extra. Okay, so breadth is 90 plus 0.3. So this is 90, right? This is 90, right? This is 90 plus this curvature which we have over here. Curvature which needs to be plastered, that is considered to be 0.3. Okay, breadth we have no problem in breadth. What about the length? Length is into in length, right? Into in length, the pipe which is running into in, right? So this length is 200, and then the breadth is 1.2. Breadth is 1.2. Because of the curvature, we have considered 30 centimeter extra. Okay. This is for flooring and roof channel. For flooring and channel. Then precast. Last thing we are left out is precast slab over the roof. Precast slab. So what we need to consider is we need to consider some bearing, right? Some bearing over here, and then some bearing over here. So they have told us to take 10 centimeters bearing, 10 centimeters, which is mentioned over here. Okay. So now what is the size of your slab? So it is 200 plus 10 plus 10. So it is 220, right? And then what is the other dimension? That is your breadth. Breadth will be same, 90 plus 10 plus 10. right? So it is 110 by 220. Okay. So that is for roof slab, right? We are done for that. Then one more we have over here, right? One more slab we have over here, right? For that also we need to consider. So it is 60, right? It is 60 plus bearing, 60 plus bearing on this side plus bearing on this side. You need to add, you will get the length. Similarly, here you can observe it is from here to here. So it is 90 plus 10 plus 10. Okay, so it is 110, and here it is 60 plus 10 plus 10. It is 80. 80 by 110. So that is for our above roof slab, and then this is for our below roof slab. Okay, so now we have calculated all of these things. We are done with earthwork in foundation. We are done with cement concrete in foundation. We have calculated brickwork, and we have calculated inside plastering, right? Inside plastering for your walls as well as your floor. Then that is done. This is done. Then RCC roof slab. One is at the top and one is over. So both all of this we have calculated. I hope it is clear. So with this, I think we can finish up with your manholes over here. And in the next class, we will start with your road estimation. Okay, road estimation, wherein we need to calculate the volume of earthwork required, required for a road construction. Okay, embankment. So that we will start in the next class. And also, if you have any doubts regarding any septic tank, soak pit, or manhole calculation, please let me know if you have any doubts in any of the things. So I hope this is clear. I hope this is clear. You can observe. So this is provided at a junction. Okay, this manhole is provided at a junction, wherein you can see this is the main channel, and then we have a branch which is coming and merging in this main channel. So wherever we have a junction, right, we have to provide a manhole. So that is why they have provided a manhole over here. So if you have any doubts, please let me know. If it is clear also, please let me know in the chat if it is clear. I hope it is clear. Yes, Kishore has raised his hand. Okay. For those who have understand, can you please raise your hand? Those who have understood. Only one guy has understood. Others, please raise your hand if you have understood. Let me check. 4 out of 16. What about others? Others are absent. Others have understood. Others, I need everyone to raise their hand. Everyone, please. Otherwise, I will explain it once more. Okay. Majority of you have raised your hands. Okay, well, you can lower your hands. No problem. So I hope you have understood. If not, please let me know. I can explain once more. Okay. No problem. I will explain until you understand. So these examples are very important, especially your manhole calculation. Okay, manholes is very important. Calculation of your manhole is very important. Maximum of your time, manhole will be asked. Okay, manhole or a septic tank. Okay, so make sure you practice this manhole calculations very thoroughly. Soak pit is rarely asked. A septic tank or usually a manhole calculation is asked. So if you are thorough with module 1, there will be no problem for you to calculate any quantity in a manhole. Okay, in the second module, it will be easier. Okay, so then I think with this, we can end over here. You can start typing in your attendance. And yeah, simultaneously, if you have any doubts, please let me know. Okay, I had planned to start with road estimation today, but I think it will be better if we start in the next class. Or should I give you an overview and finish up. We still have time. I think we have time. We have still 13 minutes before the class gets over. Okay, everyone has typed in their attendance.
Sir, time was 12:20, sir.
12:20. Class time is still 12:25, I think. Okay, no problem.